Let us solve the following problem. What amount do we want to set aside now to get $1 million in 30 years? So suppose that our account is compounded monthly. Annual interest rate is 2%. So we want to find a principal given the amount A. So we will use the compound interest formula. Amount on a contract after some years equals to principal times 1 plus R over M raised to the power N or M times T. Amount on the contract that we want to get after 30 years is 1 and 6 zeros. Equals principal is the unknown P. In the parentheses, we have the sum 1 plus R must be represented in decimal form, not 2%, but 0.02. Account is compounded monthly. It means M is 12. We divide by 12. And the time T must be also multiplied by 12. T is 30 years. 30 times 12. T is 30. And don't forget the parentheses here, especially when you use a calculator. So if you multiply by 30 and then by 12 without parentheses, your calculator will raise this parenthesis in the power 30 and then multiply the result by 12. Okay, let us use a calculator to find this, and there are two places where we must be very careful. So it is very important to keep as many digits as possible here for R over M, and in this result, so actually in all intermediate numbers until you get the final answer. I usually use Desmos scientific calculator. Let us substitute these numbers. We want to add 1 plus 0.2 over 12. So if you first find 0.2 over 12, you will get a number with a lot of digits after the point. If you take only the first several numbers, for example, if you take 5 or 6 digits, significant digits, I mean, I don't count zeros here. Significant digits are 1, 6, 6, 6, 6. So if you take only 5 from these digits, so possibly in the final answer, you will have only first 5 digits correct, and what comes after that, you cannot tell because you rounded the answer. Okay, plus 1. Then we want to raise this number to the power. So here we will use parentheses. And there is a product M, which is 12, times the number of years, 30. So for this answer also, we need to use all the digits that your calculator gives here. So let's return. So 0.02 divided by 12. And let us take not the whole number approximation of this. So 1 plus 0.001, and we will take only first 6 the significant digits, and we raise it to the power raise it to the power 12 times 30, which is 36, 0. Let us compare our results. So 18212. Then we have 089 in the correct answer and 111 in the second one. So we have taken 6 significant digits for m over r. We have got the first 5 digits correct in our answer. So you see, it's very important. If you take in your rounding less digits, you will get, actually here occasionally the 5 digits are correct. So if you take less significant digit, only 4, then here only first 4 digits are correct in this. It's still not the final answer, but here you can see it better how your answer changes depending on how many digits did you take in. So let us return to our formula. In our formula, we must divide A, 1 million, by this answer that we got on this step, and we get 549,055 point, and here on this step we can round. 5 is also rounded up, so 81. On this step you can also look how important it is to round correctly. If you take only 5 digits from the previous answer, 1.8212, you will see that first 5 digits are correct, the 6th digit is wrong. So you are close to your answer, to the correct answer, but you're still not there. MyMATLAB wouldn't recognize this answer, so be careful. Let us finish it on paper. For this right part, we have got 1.8212, 08979. To find P, we must divide the left part by this number. So you have a formula of the kind 1 million equals P times A. You must divide by this A to isolate P on the left. P equals divided by 1.8212, 08979. And after dividing, we got 549,085.859, and here we can round the answer. P is approximately 549,085.80. This sum must put on your counter this conditional interest rate to get 1 million after 30 years.